Hello and welcome to this debate on waste-to-energy plants, an event organised by the European Association representing the suppliers of waste-to-energy technology with Euractiv as a media partner. My name is Kira Taylor. I'm a journalist at Euractiv focusing on energy and environment policy. Today we'll take a deep dive into waste-to-energy plants, their benefits as well as their drawbacks for the environment, hence the title of today's event, Waste-to-Energy, the Beauty or the Beast. We have lots of speakers who will be looking at the role of this technology in Europe's green transition, what innovation we can expect over the next few years, and the environmental arguments for and against. Over the next 3 hours, there will be a mix of presentations and debates. There will also be the opportunity for you to ask questions to our final panel, looking at the role of waste-to-energy in the EU Sustainable Finance Taxonomy. Please submit your questions in the Q&A box for this discussion. I will try and get through as many as possible. But first, to kick off our event, we have Patrick Clarence, the Secretary General of ESWET, the European Association representing the suppliers of waste-to-energy technology. Patrick, thank you for joining us today. Please could you give us a brief introduction to ESWET and the campaign you've been running?
Yes, for sure. That's why we're here, actually. So thanks for the introduction and thanks for welcoming us. ESWET, as you said, is an association of waste-to-energy technology suppliers. So we are making the equipment to build waste-to-energy plants, getting the flue gases clean, sometimes cleaner than the air we suck in. And we are global players. This means we are exporting our technology around the globe, creating jobs in Europe, but also globally. ESWET is was created in order to raise awareness on waste-to-energy and the added value it has in the circular economy, the added value it has for residual waste. Because one thing is clear, and I want to say it from the beginning, ESWET is looking at treating residual waste, means waste which cannot be recycled. And that's the discussion we're having today. We're also pushing more and more landfill diversion. This is our main target. And utilizing the materials which is in this waste, the raw materials which are otherwise lost. We have different research and development activities. We're looking now in hydrogen, which is more and more coming up in order to decarbonize also the transport of the waste vans, bringing the waste to the plant, but also carbon capture and storage in order to get CO2 negative. Basically, that's why we did this event. We wanted to gather at the same table proponents and opponents of waste-to-energy. We wanted to have an open debate, a factual debate, and not an emotional discussion. Because at the end, it's all about choices. It's all about options available, in this case, for residual waste. You can wish something very hard, but you need to treat this with facts at the base. And I'm very happy to see that we attracted a lot of a higher audience, because we have more than 600 people who registered for this event, which is quite a successful topic, which we thought would be a niche topic, but obviously is not at all a niche topic. So we're looking at an open debate today on the utilization or what to do with non-recyclable waste. We did this also in a communication campaign. We called it The Beauty in the Beast. It's not me, the beast, obviously. And we will have in there, or we looked in this, and you find it on our website, also how the waste is recovered, the energy, the material from the waste is recovered. And we pushed different topics, taking care of our own waste in Europe and not dumping it around the globe. We talked about recovery from minerals, but also materials like aluminium, gold and metal. And a sneak preview is that we have 650 people's waste is making one golden ring. So that's something very interesting, which you can discover later on. And we also look, as I said before, at hydrogen and CCS, which is part of this Beauty in the Beast. So therefore, I hope you will enjoy this debate with different point of views, with facts on the table in order to make up your own opinion. Please.
Patrick, and yes, as you mentioned, we will be watching some of the videos, including that amazing fact about wedding rings. So before we move on to our next discussion, we have a short video to show you all about material recovery from waste-to-energy.
As a society, we strive to reduce waste, reuse what we already have, and recycle what cannot be reused. But for some objects that we throw away, it does not stop there. Non-recyclable waste is usually associated with something unwanted, but it can be used as a source of energy and heat. And gold can be recovered as well. Yeah, that's where the story gets exciting. The controlled combustion process generates electricity and heat out of non-recyclable waste. The process also produces some leftovers, the bottom ash. And the bottom ash includes a number of perfectly reusable materials, such as aluminum, copper, iron, steel, or zinc, to name a few. Surprisingly, silver and gold can also be found in these leftovers. That being said, how much gold do we exactly recover? On average, it would take about 650 Europeans' annual residual waste to produce one golden engagement ring. Impressive, right? But what about other materials? If we consider all the waste-to-energy plants in Europe, it would be possible to recover almost 1.2 million tons of iron and 250,000 tons of aluminum. Worldwide, the extraction of raw materials is highly energy-consuming, emits a great number of greenhouse gases, and pollutes soil, air, and water. These metals are widely used in electronics, such as smartphones and laptops, but also batteries, solar panels, or wind turbines. Improving the recovery of secondary raw materials through waste to energy can make Europe more resource efficient. And this is how the story goes on for non-recyclable waste.
Now we turn to our first debate on moving towards a circular economy. The European Commission has emphasised that one of the key elements to reaching climate neutrality is to decrease reliance on primary materials and move towards more reuse and recycling. To discuss how waste energy contributes to this, I'm joined by Piotr Buksak, who is Senior Policy Officer for Waste at the European Environmental Bureau. He's online. And Ezra Stengler, with me in the studio, the Managing Director of the Confederation of European Waste-to-Energy Plants. Thank you both for joining us. Now, I believe each of you will give a short presentation and then we'll move on to some questions. So, Piotr, you have the floor. Would you like to give your presentation, please?
Thank you, Kira, and good afternoon to everyone. I hope you can hear me, and I have a presentation, so please, I ask the technicians to put it on. So yes, my name is Piotr Barczak, and I thank you for this invitation. I've been working on the EEB, European Environmental Bureau, for many years already, covering all the waste policies, including the advocacy on the Waste Framework Directive and other waste directives. Please, next slide. First of all, I wanted to just clarify the definition. Waste to energy, as it is, next slide, please. It is mentioned here often. For me, it is a broad concept. It is not only about incineration. It is also about anaerobic digestion. So the fermentation of organic waste, which gives us biomethane. And if it comes, of course, it has to come from bio-waste sources, which are clean. This waste later on, after stabilization, can be used again in the circular economies. In this graph, from resources extraction and imports, because Europe is poor in resources, but also to cut from the leakage of materials, which is incineration with energy recovery or not, and landfilling. Next slide, please. And this has been a goal of the European policies for many years already, together with the first circular economy package in 2015, and actually before, and continuing even now. This has been the aim. Our aim is to increase recycling up to at least 65% in the next decade, or 70% in packaging. But this is just the minimum. But there are other very important new rules that are, in fact, in contradiction with the push to burning more waste, which is mandatory separate collection of certain streams, any other actually mandatory streams, mandatory separate collection. Also, there is a ban on incineration and landfilling of separately collected waste. There are also, next slide, please, new rules calling for stringent EPR rules, so that all producers will have to be responsible and put as much funding in order to recover their waste, recover the materials contained in that product that they're produced and put on the market at the end of life, instead of just putting them in the landfill or in the incinerator to burn. In 2020, we had the second circular economy action plan, which is even more stringent in terms of circular economy, even more looking at the way how we design products. So if the Commission goes ahead, and they do go ahead with their very ambitious eco-design rules, we will have less and less difficult products, difficult to recycle. So this stream will definitely will go down. There are also rules to ensure less waste generated and cut residual waste. Please, next slide. Such as also food waste, there will be a goal to cut by half food waste. But very important for this discussion today is a goal that by 2030 we will have to cut the amount of residual waste, so non-recycled waste, by 50%. So just take the number today and cut it by 2 in 8 years from now. Of course, to that goal, there will be different activities, legislative new initiatives such as eco-design, such as also essential requirements for packaging and other streams, plastics, textiles, also industrial waste. So that's it. These are the goals, and this is very important to bear in mind that no other policies, no other decisions, be it at national level or European level or local level, should not contradict this major goal that is there. There will be further actions on reducing single-use items and single-use items, basically. But I wanted to zoom into our mixed waste bin. This is a report done by RAP, it's a government organization in UK, who they look at what is contained in our mixed bin, and it's large. UK has a large bin, and many other countries too. And when we look inside what is considered to be non-recyclable, which is mixed waste, actually, when we look at the materials in it, the products in it, we see that more than half of it could be readily recyclable already today with the current technologies. Another quarter of the bin could be potentially recyclable because the technologies of recycling, of sorting, are also very much improving. Then there are groups that could be substituted. So in the end, next slide, we will have very little still amount of truly unrecyclable waste. This graph shows you in kilograms per person. So if we actually add the difficult to recycle or substitute materials, we would have up to 50 kilograms of residual waste per person. And that is, even if we go very accurately, only 20 kilograms per person of difficult to recycle waste. And that is the goal. So actually, when planning the capacity for residual waste treatment, we should not go beyond, I would say, those 20, or if we want to be a bit more, less conservative, let's go to 50 kilograms per person. But that's maximum. Today, many countries, they have their capacities put at 200 or even more kilograms per person, such as Denmark. And many countries are going this direction, unfortunately. So next slide. The best strategy. This is another example, very precise from Italy. When we show in Italy, in one of the regions or municipalities that is called Complementary, where they have quite well performing separate waste collection. And what we see that even in the residual bin there, we have about half of it that could be still recyclable. So very much showing the same what the UK study showed. Very interesting is that even 13, almost 14% of that bin are the nappies. And we know there are solutions for single-use nappies. There are difficult today, those single-use nappies today, but there are solutions. There are substitutes, such as reusable nappies, and that is what many different NGOs are calling across Europe. And this is really readily available and easy to use. So next slide, please. This takes me to a conclusion that the best way to address residual waste and incineration and landfilling in the same time is to put a cap on waste generated. Prevention has not been very high on the agenda, unfortunately, by the European legislation, but that is going to change. As I said, there are prevention goals going to be revised in 2024, And already now the Commission has announced, number 10, please, slide. And the Commission has announced already that that by 2030 we need to reduce residual waste by 30%. And if we have targets, the policies prove to be effective. And countries are in majority following them. And then we have results. Without previous targets on waste prevention, we didn't have any achievements. That's clear, but there are going to change. Next slide, number 10, please. So that next one. So now going a bit to data. Oh, these are very small numbers. I'm sorry, but this comes from the report by Tomra and Eunomia. It shows just compares two ways of treating residual waste. Either we go like it is going to it is being done today, straight to incineration. So we take residual waste and they are sent to incineration, which generates a lot of CO2. And actually my colleague from Zero Waste Europe in the next session will speak a lot about this. So incineration is a huge emitter of CO2, as compared to another scenario where before putting residual waste into the residual waste treatment, being it waste incineration, there is much more advanced sorting happening, and there are new advanced techniques such as hot wash and color sorting. It is going much better. Apart from all the facts that I said before, that we are going to have much better designed products because of eco-design and essential requirements for packaging and much more stringent separate collection, residual waste is going to be smaller. But even if we still have residual waste, before going straight to incineration, we have to sort residual waste again to stabilize the bio-waste fraction, which is still contained, as I showed you from the Italian example, up to 16% of residual waste is still bio-waste, which is perfectly recyclable. So one way is to stabilize and therefore minimize the methane emissions from landfilling. And very often this argument is brought by waste incineration promoters, methane from landfilling. But this is going to reduce also maximally, because what is the reason of methane on the landfills is the bio-waste. We have, in next year, we will have mandatory bio-waste separate collection, 100% for all of the countries. Even if some fraction will still be in the residual waste bin, it is going to be stabilized. So that's on the bio-waste part. But on the recyclables part, much more advanced sorting through MRBT, so mechanical material recovery and biological stabilization techniques. We are going to extract even more metals and gold, as it is compared to incineration, from those residual streams done from residual ashes from waste incineration. And on top of that, we are going to emit less CO2 emissions, much less CO2 emissions as compared, as shown in this report. Next slide, please. So, yeah, just not to forget the issue about jobs creation. Incineration is not creating jobs. They are working full-time on few shifts, but it's really just few persons. Recently I visited the Vienna incineration plant, and there are like 8, maybe around 10 persons working there. So it is very effective in terms of labor, but it does not create jobs and value, that the jobs that are coming from the value of materials that would otherwise be recycled or through reuse. Next slide. And really very important, we are in a climate crisis. We have kids on the streets. We have no margin left to build any new CO2 emitters, any new either coal or gas or waste incinerators that we will have for next decades, because this infrastructure is expensive and it takes a lot of resources to be paid back. So no, if we really speak honestly about climate neutrality and CO2 reduction, there is no room for more plants that emit CO2 in the atmosphere. Next slide. There are few very good reports that say what to do about residuals, and really it's very important to know that waste incineration, or let's call it burning waste incineration, it's not the only way to treat residual waste. And really, it's the most expensive. As we compare incineration with capex around 1,000 euro per ton installed, to MRBT that I mentioned before, that is between 200 and 400 euro per ton installed. That is much less expensive for MRBT. So if we use public funds, and all of this is public funds, either it's EU, which actually is going to be not possible to access anymore because of taxonomy, but if it's local and national funds, it is also not, waste incineration is not the most intelligent way to use public resources. Next slide. Actually, I almost finished now. I invite you to check this report by Zero Waste Europe, and I know Yannick will explore more about this next in the next panel. So next slide. So just about some solutions really here. We, with the European Green Deal, when we look at the objective of having products sustainable as a norm, we have to use all those economic incentives as well. And EPR, modulation of EPR towards eco-design is really helping here. There is much more deposit return systems being deployed around Europe for different packaging streams, and maybe why not also to other streams. There are green certificates and taxing incineration. I would say if there is a role of incineration to play in circular economy, there is one role. I can say that there is a role, which means increasing the gate fees so that to disincentivize this activity in view of the municipalities that have to choose either they're sent more to recycling and composting, or they will have to face very high taxes when putting their waste on landfill or in incineration. For this also there is ETS that is going to play a role. Of course, we have other incentives, economic incentives to increase separate collection, which is important, and as I said, it's mandatory for many streams, and also to boost recycling market. And many could criticize why recycling market is not working properly. It is because in the public funding we don't prioritize recycled content yet as much as we should. European Green Deal and the Circular Economy Action Plan has this objective. So these are the tools that really will help us to go towards circular economy and reduce the amount of residual waste still present. Next slide. Well, this is just some more resources for you to get. I get you will get the PDF later on. And yes, we have ambitious directives in European Union, but how are they implemented? I agree, it is not easy at national level very often, but there are good examples. And here in those materials, we gather best examples of different legislations across Europe, sometimes even at city level, that boost waste prevention, reuse, and separate collection. So there is no need to reinvent the wheel. There is no reason to cry and say that we will still have tons and tons of residual waste. It is going to be reduced much if only political will be, if only there will be a political will. So up to the next or the last slide, which is my contact details. Yeah, I'm sorry for those problems, but if I can reply any questions still, I would gladly do.
So yes, I will talk. I hope I can be heard now. I will talk about the double role of waste to energy. First of all, the essential task of waste to energy is a hygienic one. Sounds strange. Waste to energy treats the sorry.
I think we've got a bit of trouble with the feedback in the studio at the moment.
Too much echo.
Okay, please keep going if you can.
Should I?
Yeah.
Okay. For me, it sounds good now. Okay, so first task is a hygienic task to treat the pollutants embedded in the waste in a hygienic waste, acting as a pollutant sink, avoiding that pollutants are spread into the material cycle. Secondly, waste-to-energy operators try to generate as much energy as possible embedded in the waste and also create secondary raw materials, for example, from the bottom ash, where, for instance, metals can be recycled. Next slide, please. We very much support the waste hierarchy, which means prevention first, and then prevention and reuse, followed by recycling. And in order to achieve quality recycling, as I still think quality matters even more as just quantity, in order to achieve quality recycle, we need source separation, effective source separation, so that the materials are kept clean. Once they are mixed, it's difficult to recycle it into quality products. So source separation is really, really key. And that also makes sure that only the non-recyclable waste goes into the next step in the waste hierarchy, for instance, into energy recovery. Next step, please. Next slide. Can't we recycle everything? Not now. So there are still dirty, mixed and contaminated materials in the waste. Also, after several circles of recycling, the material gets degraded, so you cannot produce quality products any longer. And there are materials containing substances of concern which are even not allowed to be recycled. So these are currently the limits of recycling, and that's where waste to energy can come in. Next slide, please. So in the recycling process, articles that contain substances of concern can contaminate the respective waste streams. And according to modeling studies undertaken by the European Commission, it may take centuries to decontaminate a recycled waste stream. And this is why, time matters. And as long as we still produce these materials, which are difficult to recycle, we rely, and we can rely on waste to energy to deal with these difficult materials. Next slide, please. Next slide, you can skip this. And this is a graph that we update every year. It's based on Eurostat figures, and it shows the green bar is recycling in the member states, the yellow is waste to energy, and it shows that in member states where you achieve rather high recycling rates, they also rely on waste to energy, because waste to energy is needed to treat the rejects from sorting and recycling facilities. So the one goes hand in hand with the other. And you see that these member states on the left side also don't rely on landfilling anymore, whereas on the right side, the member states, that's the red bar, which landfill still a lot, they also achieve low recycling rates and have practically no waste to energy. So again and again, the conclusion is every year confirmed that waste to energy and recycling go hand in hand in order to divert waste from landfills. And also waste to energy contributes to quality recycling because it is a reliable treatment for the rejects from recycling facilities. Next slide, please. And it's also in line with the waste hierarchy to try to reduce as much as possible landfilling of waste that can be recycled or recovered. And this protects soil and groundwater from potential contamination. It also saves space, which is quite rare in Europe. It prevents microplastics being blown by the wind to water bodies. And of course, it harnesses the material and energy content of residual waste. And it also avoids the creation of greenhouse gases, because methane, which is emitted from landfills, is a very potent greenhouse gas in comparison to CO2, normal CO2 in mass. And we always say it's about 28 times more potent than normal CO2. But if you would look at methane emissions from landfills, not only in a 100-year perspective, but in a 20-year perspective, then methane is even more than 80 times more potential than normal CO2. And this is why in a recent UN report, they recommend to look into a 20-year perspective rather than a 100-year perspective when it comes to methane emissions, because we are quite in an emergency case with climate. Next case, slide, please. And reducing greenhouse gases is in the waste management sector their diversion from landfill is a main contribution to greenhouse gas mitigation. And this is a quote from the German Environmental Protection Agency, which did some calculations back to 2015, but it's still valid. We have a huge potential to reduce methane emissions from landfills if you divert waste that can be recycled or recovered from landfills. There's always still something left which can't be recovered or recycled, but and needs to be landfilled. But what can go higher up the hierarchy, that should be treated higher up the hierarchy. Next slide, please. To conclude, what is waste to energy's double role? It contributes to sustainable waste management, as well as to energy and climate policy. First of all, the hygienic task, but additionally it substitutes fossil fuels by producing the energy embedded in the waste, and it helps us also to become less dependent on fossil fuel imports, and it is a local energy source, and it is affordable because the waste needs to be treated anyway. And additionally, it helps, together with recycling, to divert waste from landfills, avoiding methane emissions. And last but not least, waste to energy recovers valuable materials from the bottom ash, which is the remaining part after the incineration process. And via, next slide please, and via recycling of metals from bottom ash, for instance, there's in 1 ton of bottom ash, there's about 10% of metals. And if you recycle them, then you can save per ton of recycled metals about 2 tons of CO2 emissions. And in Europe, it's about 3 million tons of CO2 equivalent emissions that are saved with metal recycling from the bottom ash. And the remaining part, that's a mineral part of the bottom ash that can be used for construction purposes. You see here on the slide a brick which is used for construction purposes. And last slide, please. To finish, another thing that is more and more explored, and Patrick mentioned it in the introduction, that is hydrogen production. So if you have excess energy, you can put it into an electrolyzer and produce hydrogen. And for example, in Wuppertal, there are city buses fueled by this hydrogen produced by the Wuppertal Waste to Energy plant, and it replaces diesel. So the city buses run by hydrogen and contribute to clean public transport.
Maybe we can turn to Ezra for our first question. Reaching a circular economy is essential for the green transition. What will it take to close the loop and ensure material is recovered? What role do you see waste to energy playing there?
I agree that recyclable waste and materials should not enter waste to energy. It is there for the waste that is difficult. So Piotr mentioned it already, eco-design is very important in order to avoid that we have too many materials which cannot be recycled. But this will take time. And until we reach this status, we should rely on waste to energy as a sustainable way to treat this residual waste, closing the loop.
So is it something you see as continuing to be used? Because presumably as more residual waste is cut down, there'll be less resources for waste to energy to burn.
In a perfect world, we would produce 0 residual waste, and then then indeed you're right. Then waste to energy would be not necessary. But unfortunately, we are not in an ideal world, and we are still producing residual waste. And so far, our society was not very successful to reduce our waste generation in Europe, and worldwide predictions go even up. So we should indeed do a lot of efforts to reduce our waste generation. It all goes along with effective eco-design. But as long as we are not there, I think we should be happy to have a reliable treatment for that.
And you talked a lot about how recovery is done within waste to energy plants. I think there is still a certain extent where people hear waste to energy and just think of incineration and that there is material lost. How much material is actually lost and what can be recovered? And do you think waste to energy needs sort of a shift in how people see it?
Yeah, the shift would be indeed good in the way to people recognize the efforts the waste to energy operators are doing to do the best with the leftover, which nobody wants to. It's not that waste to energy operators are chasing to get waste into their ovens. It is that it is really the residual part which nobody can do anything better with and wants to get rid of. So, and then of course you should try to produce as much as energy out of it, but also you can still take some materials out of it, as I just mentioned, the metal recycling from the bottom ashes.
And I know we hear a lot from maybe the recycling industry that they actually need a stronger secondary raw materials market. Is that something that you think also needs to happen?
Definitely. I think we need some incentives there. I see it also with bottom ash. So using bottom ash more in construction works would also help. So incentives to use more recycled materials would be definitely good. A market would be good as well, and we need to develop that market. But what is key in order to achieve a workable market is quality. So quality really matters.
And I guess the criticism would be, well, actually, if you have all of these waste to energy plants, then presumably you do need quantity as well, because they all need to keep going. Is that something which is an issue for you?
It is not an issue for now, because now we still produce more waste than the European waste to energy plants could treat, more residual waste. Should we significantly reduce waste generation, the plants can be flexible and treat less waste. And then, of course, if after a long while it's visible that it's not economic anymore to operate the plant, then it's closed. It happened in Rotterdam some years ago. There was a decision, should we modernize the plant? It was up for modernization. Or is the economic situation not there any longer to justify it? And then it was shut down. So you can react, but I wouldn't shut down the plants before we significantly reduce the residual waste.
Thank you, Ella, for joining us in the studio. Next, we will be looking into the environmental impacts of non-recyclable waste. But first, we're going to see a video on community engagement with waste to energy plants.
The Danish word hygge defines the happiness people can get thanks to the atmosphere surrounding them. And in Copenhagen, there is a special place where hygge can happen, Copenhill. Its peculiarity? Copenhill is a waste-to-energy plant with a landmark architecture offering Copenhagen a brand new mountain and the perfect set for hygge moments to the whole community. Here, visitors can find an all-year skiing slope, a hiking track leading to a rooftop covered with alpine vegetation, as well as the world's tallest climbing wall, 80 meters high. After all this, they can enjoy a moment of relaxation in a food kiosk located at the bottom of the hill. Below all these attractions, there is a fully functioning waste-to-energy plant, equipped with state-of-the-art technologies to safely manage the residual waste produced by households and industries around Copenhagen and not suitable for reuse and recycling. In return, Copenhill provides electricity to 80,000 households and heating to 90,000 apartments, and recovers up to 90% of the metals found in the treated waste, contributing to the circular economy. Copenhagen is the second best city in Europe in terms of air quality. It aims to become the first carbon-neutral city in the world by 2025, and Copenhill is part of this journey. Already at the forefront for the use of pioneering technologies, the plant is planning to integrate carbon capture and storage utilization in its operation to collect nearly the totality of its CO2 emissions. With its multiple features and its modern technologies, Copenhill is a lighthouse project showing the numerous ways waste to energy can benefit the community it serves.
Welcome back to this event on waste-to-energy plants. We've looked at the role of waste-to-energy in creating a circular economy, and we are now turning to our second debate on the environmental impacts of non-recyclable waste. I'm joined by Yannick Vart, Climate, Energy and Air Pollution Programme Coordinator at Zero Waste Europe, and Tom Kroijmans, the Carbon Capture, Usage and Storage Working Group Chair at ESWET, to discuss this issue. Once again, we will see their presentations, and we will hear from both the speakers and then move on to some questions. So to start, Yannick, I believe you're going to take us through what you see as the shortfalls of Europe's residual waste policy. You have the floor.
Can we have the slides? Okay, here we go. It works. Okay, can you put the first slide, please? So let me start from the statement that clearly the current way of managing residual waste is outdated and broken for different reasons. The main one, I would say, is that the current focus on limiting landfilling has led to having a very incineration-heavy approach to managing residuals, and this approach is clearly unjustified. And what it does, it actually contradicts many of the objectives of the Green Deal. And I just let me go through some of the main ones. Such as the transition to a circular economy, net zero emissions by 2050, and the zero pollution strategy. Next, please. So I think Piotr already referred to some of the studies which are on analyzing the composition of residual waste. And what is quite clear is that residual waste, or so-called mixed waste, is actually largely recyclable and compostable. And the right thing to do is to recover those materials. And there are a number of studies that say that doing so is needed in order to meet our climate targets. So I would just like to mention here one which came out last week by Eunomia. It was done for TOMRA, which estimated that about 500 million tons of CO2 would be saved globally per year by 2030. And I would also like to highlight the little scheme that what's on the right side. You can see clearly this is a study done by DEFRA in the UK, which shows that 53% of mixed waste or residual waste is recyclable readily, and another 27% is potentially recyclable, which is already more than 80%, 85%, if I'm not wrong, is recyclable. And there are other studies and other reports, including the European Commission ones, that acknowledge this fact. So let's move to the next slide. I would say we live in a climate urgency, and we have to realize, and I think we are already seeing some acknowledgement by the industry and some other stakeholders that waste burning is very, very bad for climate. If you look at the studies on, for example, municipal waste incineration, we see that at least 52 million tons of CO2 were emitted alone in 2018. And I would say that this study is already outdated because we have many more incineration capacities in Europe. And they are being built as we speak, really. Probably a dozen of them, so even 20 or 30. I don't know exactly the number. And what is important to know is that those emissions are underestimated. What we know is that, and there's an upcoming study which will say that the plastic which ends up in mixed waste is underestimated, and therefore the total emissions from waste incineration could represent at least 7% of European carbon budget in a 1.5 degree scenario. And I think it's also important to acknowledge the fact that waste incineration is not low carbon. In fact, it's twice the carbon intensity of the current electricity grid, and it's much more carbon intensive than, for example, burning gas. And you know, we are discussing now if gas should be a transition fuel. If you compare it with the waste incineration, clearly it's much cleaner. But of course, we don't want it as well. So let's go to the next slide. Just here, a little scheme, if you can, where you can see what is happening with waste incineration emissions. So you can see the red line is showing where we are going already with in terms of waste incineration emissions and currently, and then the other line, black, I think it's black in this, shows where the total emissions of European Union are going. And you see very clearly that those emissions are going in a very opposite direction. So we are talking about a huge growth of emissions. It's very clear that we cannot continue putting CO2 into the atmosphere. So this has to be clearly addressed. So let's go to the next slide. And I also wanted to say just very quickly about the fact on zero pollution. So we know, and particularly in other regions, European waste incinerators are often promoted as safe and emitting very little toxic emissions. But the reality is, or the truth is the regulation is very partial still, and the emissions are limited, where the emission monitoring is quite limited still. And this applies both to the emissions, but also to the emissions from residues of waste incineration. And this is much more limited when it comes to very toxic compounds, such as the persistent organic pollutants. I just wanted to say that we, sometimes those emissions, they go unperceived because, it looks like we are measuring our emissions, and it does look like we are emitting very little. So that's why we have started to do biomonitoring. And the studies around the waste incinerators very clearly show that we have a high levels of dioxins, furans, and some other persistent pollutants. And those chemicals often they are very hard to break down, and they will stay there forever. What is interesting about this is that we are seeing high levels of pollutants in the vegetation, and particularly in chicken eggs around on the facilities. So we have started to recommend not to eat any homegrown vegetables or chicken eggs, particularly the ones that can roam around the incinerators or the houses in the gardens around the incinerators, because they have a very high levels of dioxins. So just by eating one egg, or 2 eggs maximum, you already have a higher level that recommended by the legislation. And then let's move to the next slide. In terms of course, we should not just talk about what are the problems, but we also need to look what we can do in the future. It's clear that the residual waste or mixed waste is not going to just disappear overnight, even though we have a clear goals in place. We want to halve it by half by 2030. But in order to, I think the three arguments that I just mentioned, they make a very strong case for the revision of the current mixed waste or residual waste policy. And it needs to focus on 2 things: material recovery, in order to really remove the materials that can be used, and then secondly on a biological treatment to stabilize the rest before they are landfilled. And by doing that, we estimate you can as minimum minimize the amount of waste by half or even more. They already, and this is not utopia, there are already cases happening this. There are a number of studies that have come out during the last months showing that this is possible and it's a must. But obviously this is not going to happen just by wishing. So we need to have policies in place. First of all, we need to move away from talking about limiting landfilling, because this only what it does is that it moves waste from incinerators, from landfills to waste incinerators. So we need to have a policy that starts to address the generation of residual waste as a problem and not landfilling. In fact, if you look at some of the studies, there are studies that show that landfilling is even better option than incineration. Some of the other things I already mentioned, we need to mandate mixed waste sorting in order to recover recyclables. There are already cases there recovering 75% or more of plastics, metals, even textiles, paper, cardboard. It really depends on some of the other factors. We also need to redefine the landfill target. It's not very helpful that we have a landfill target which talks about limiting percentage of landfills. We need to clearly limit landfilling of untreated waste, which is the problem. This is the issue that creates methane. It's not landfilling by itself. In fact, landfilling, if you treated waste, could be a better option in terms of climate, because it's the biological part that emits greenhouse gases. And then I just also wanted to finally mention that we also need to have a clear definition of pre-treatment, because the current definition is often misused. And some of the countries, they think it actually refers to a kind of thermal treatment. So this needs to be redefined or clarified. And then let's go to the last slide. I just wanted to say also some of the benefits of doing material recovery and biological treatment. First of all, they are more scalable, much more scalable. They are very cost competitive when compared to incineration. It's less than half of the price. They are easy to implement. It doesn't take years of permitting and so on.
Okay, thank you, Yannick. Apologies for the technical issues there. Tom, we can now turn to your presentation. Please go ahead.
Thank you very much for the introduction and a warm welcome to the public. Today I'm going to speak about how waste to energy keeps the material cycle and the environment clean. So next slide, please. So waste to energy is an integrated part of the waste hierarchy, which prescribes we should prevent, reuse and recycle our waste. If that's not possible, we should maximize the recovery of energy and materials out of our waste. That's where waste to energy is located. We are located in the recovery part. The least preferred option, according to the waste hierarchy, is to dispose or to landfill our waste. Waste to energy, so the recycling and the recovery part, they are complementary to each other. So next slide, please. So we say that the next slide, please. So we say that waste to energy is complementary to recycling. With recycling, what we intend to do is we want to recover materials and bring them in the loop. However, we must be aware that certain toxic substances, they can accumulate in this material loop. So we don't want to have an accumulation of toxic substances, in the end, harming our environment, harming human beings. Waste to energy plays a key role in keeping this material cycle clean. Next to that, recycling is finite. There's non-recyclable waste, and we also have post-recycling waste that needs to be treated as well, in accordance to the waste hierarchy, and the safe way to treat that is via waste to energy. Next slide, please. If we look at the current situation in Europe, we see there are two types of member states. Member states with a high rate of recycling, shown here in green, and member states which mainly rely on disposal or landfilling their waste, shown here in red, and sometimes it's even more than 80% of their waste that's still landfilled. For these member states which mainly rely on landfilling their waste, even if we in the future maximize our efforts on prevention, reuse and recycling, there's still a key role for waste to energy to play to make sure that these material cycles are clean and that we safely treat our non-recyclable waste. So as a matter of fact, the next slide please. So as a matter of fact, waste to energy supports recycling. So recycling is always the preferred option. However, every time we recycle something, the quality of the recyclable decreases. This means that certain fractions, that recycling is finite and that not everything can be recycled. Next to that, we want to keep these material cycles clean and we want to destroy and eliminate toxic substances from these material cycles. Next slide, please. Going back to the waste hierarchy, the least preferred option is landfilling. Landfilling is known to emit greenhouse gases like CO2 and methane. And I want to highlight these methane emissions. Methane is a much more potent or has a much more higher global warming impact compared to CO2 on a per molecule level. And in fact, the latest UN report showed that 40% of the current global warming is linked to methane. 40% of the current global warming is linked to methane. 20% of these methane emissions come from bad waste management. So if we look on a global level, 70% of our waste is currently landfilled, leading to methane emissions. Next to that, when we put materials in a landfill, we lose resources. A landfill doesn't allow to recover energy or materials, or very little energy sometimes. Landfills, when material end up, or when waste end up in landfills, the contaminants also end up in the landfill. And it's just a matter of time before these contaminants will pollute our soil and pollute the groundwater. Next slide, please. So one step higher in the waste hierarchy is waste to energy. So with waste to energy, we avoid these methane emissions. We allow to recover materials and also energy. We reduce the volume of the waste with more than 90%, safeguarding valuable land. Next slide, please. Next to that, with waste to energy, we safely treat non-recyclable waste. So unwanted substances, they are present in the waste. It's just like that. With waste to energy, we destroy these toxic substances where possible. This is due to our high temperature process. However, certain toxic substances cannot be destroyed, like for example, heavy metals. So what we do is we filter these materials out, we concentrate them in certain fractions, which we then can treat in a controlled manner. I also want to highlight that with waste to energy, we have a very advanced flue gas cleaning system. So approximately 1/3 of the footprint of a waste to energy is flue gas cleaning. This flue gas cleaning consists out of a different set of filters and different set of scrubbers, making sure no harmful pollutants end up in the environment. We operate under very stringent emission limits, which we respect. Next slide, please. So it must be said that with waste to energy, we have an incineration process and that we produce CO2. As a rule of thumb, we say that every ton of waste that is incinerated creates 1 ton of CO2. I want to highlight that 60% of the CO2 we emit is of biogenic origin, meaning that when we emit it back into the atmosphere, it's carbon neutral. So what is CO2 of biogenic origin? This is CO2 which was already present in the atmosphere and, for example, via a tree, ends up as non-recyclable paper in our waste. When we incinerate it and it goes back into the environment, it's carbon neutral. On the other end, 40% of our CO2 is of fossil fuel origin. So there we have a footprint. Looking at that footprint, it's much lower than other other energy producers like, for example, coal and natural gas. Next to that, I want to highlight that we also partially offset these emissions. How do we do that? By mitigating the methane coming from landfill, mitigating fossil fuel consumption for energy production, and mitigating the exploitation of virgin raw materials. I want to come back to this biogenic CO2, which is currently CO2 neutral. And as a next step for our sector, instead of becoming CO2 neutral, we want to become CO2 negative. So please do the next slide. So when you combine a waste to energy with a carbon capture and storage facility, we become a carbon dioxide remover. So instead of releasing this biogenic CO2 in the atmosphere, being it carbon neutral, now we want to capture it and store it permanently under the ground so there are no emissions anymore to the atmosphere. This means we are a net reducer of CO2 out of the atmosphere. The netto concentration of CO2 in the atmosphere is decreased. And the Climate Technology Center and Network, they did a calculation. For a 1,000 ton per day waste to energy plant, emitting 1,000 tons of CO2 per day, we combine it with a carbon capture and storage plant. We see that there is a net reduction of 500 tons of CO2 per day. So every day we operate this plant with a carbon capture and storage facility, 500 tons of CO2 are extracted from the atmosphere and permanently stored in the ground, so they cannot contribute anymore to global warming. Speaking about global warming, the IPCC mentions in their report of 2018 that carbon dioxide removal technologies are a crucial part to keep our global warming below 1.5 degrees. As a matter of fact, they are an intrinsic part of the strategy to meet our 2050 carbon neutral goals, as you can see in the graph on the right hand below. And even if we go beyond 2050, we want to become carbon negative. So here, carbon dioxide removal technologies play a crucial role in this strategy. Waste to energy combined with carbon capture and storage is one of the few technologies which is able to capture, to extract CO2 out of the atmosphere. Next slide, please. So I want to summarize here. Waste to energy, we are the preferred option for waste that cannot be recycled and would otherwise be landfilled. We are complementary to recycling. We keep material cycles and the environment clean from pollutants. We recover energy and materials from non-recyclable waste, and we have the potential to become carbon negative when we are combined with a carbon capture and storage plant. Thank you for your attention.
For the presentation, and we have some time for some questions. Yannick, I'd like to start with you. Europe is still miles away from being anything close to a circular economy. So if we can't recycle and reuse everything, what do we do with what's left of our waste?
Well, thank you. So, as I mentioned at the very end, it's clear that we're not going to just have a circular economy tomorrow. So it's going to take some while. And from the climate perspective, but also from the other perspective, like transition towards the circular economy and toxicity perspective, we need to focus on material recovery and biological treatment. That's the best. It's clear we can't rely on combustion of waste as a way forward. There's no way we can have a carbon capture and storage on every single waste incineration plant in Europe. There are too many. There are so many limitations, and it's simply also not the priority sector, I would say. So yeah, I think, and that would only address some emissions from some of the plants. So as I said, it has to focus on material recovery and biological treatment.
And very quickly, and then I'll move to Tom. Are you in favour of a landfill ban? Do you think that would help?
I think the waste hierarchy prescribes that landfilling is always the last resort. So I think we should follow the waste hierarchy, because landfilling produces methane emissions, we can't recover our resources, and we shift actually the burden of all these contaminants to the future generations.
Yannick, would you be in favour of a landfill ban?
No, absolutely not. It's not the smartest thing to do now. Because it would just lead to probably waste incineration, because waste incineration is in no way limited. There is no limit for waste incineration, and this is something that it's the second last at the moment in waste hierarchy. So it's the second last favorite option that we have, and it has, as I just mentioned in my speech, a lot of issues in there. This is not a way forward. So we need to what we need to do is to limit landfilling of untreated waste.
And Tom, can the waste to energy sector offer a sustainable treatment in accordance with the zero pollution ambition? And how would that work?
So with waste to energy, recycling is always the preferred option. So what we intend to do is we support recycling. We want to keep the material cycles clean. We treat non-recyclable waste, so waste that cannot be recycled. We make sure that toxic substances are destroyed where possible. If they cannot be destroyed, we filter them out, concentrate them, and make sure they can be treated in a controlled manner. Next to that, in terms of pollution, we avoid methane emissions, and when we combine waste to energy with carbon capture and storage, we can create negative CO2 emissions, meaning that we are reducing the concentration of CO2 in the atmosphere to meet our climate target goals.
Yannick, would you agree with that, or do you think there are still issues in this area?
Well, I would say I don't agree at all with the going ahead with waste incineration. There are already alternatives out there. I'm just talking about most of the waste actually being recyclable, and that's very clear. And there are studies there that say so, done by the government, by the European Commission, many different sources. So that has to be the way. And unfortunately, the problem at the moment is that waste incineration is the easiest way to continue. Just simply burning the waste rather than recovering those materials. And the reason for that is that we have economics to fix it. There is no really economics to support the material recovery. So that needs to be changed. So we need to really have a radical change of our current policy when it comes to mixed waste.
And we hear a lot about EPR schemes, so extended producer responsibility. Is that something that would help us cut down on the amount of waste in Europe? And how does that work with waste to energy plants, Tom?
I think the EPR system is a very good system. The impact on the waste on waste incineration, I'm not familiar with that topic, so I cannot answer that question.
EPR?
Yeah.
Well, I mean, EPR is clearly one of the tools that we can in order to help kind of the separate collection and sorting of materials, but it's not the silver bullet. We really, when it comes to mixed waste, I honestly think the first thing we need to do is to set a concrete target to start limiting it. And it's already, I mean, there are countries or places where this is happening.
Brilliant, thank you. We're coming to the end of our time, but I would invite you both to maybe give a minute of what are your key takeaways from today's event. Tom, maybe you first.
As I mentioned in my presentation, waste to energy is there to safely treat our non-recyclable waste, to destroy pollutants, and to keep material cycles clean. It must be noted that we produce CO2 emissions. However, when we can be combined with carbon capture and storage, we have the potential to become carbon negative, meaning that we reduce the CO2 concentration in the atmosphere, so we are able to meet a global target of keeping the temperature increase below 1.5 degrees.
Brilliant, thank you. And Yannick, your final word for this debate.
Yeah, for me, it's I think what I started by saying is that we really need to fix the current policy and the way we manage residual waste. We need to move towards a more sustainable way of managing it, and the way forward is material recovery and biological treatment. That's it.
Thank you both for joining us. And of course, one of the big concerns around the environmental impact of waste is what happens if and when it goes outside of Europe. Our next video looks at exactly this, and then we will be back for another debate in a minute.
Having a garden is real luck. This is why people usually take care of their backyard, decorating it and, of course, keeping it clean. But what if a person disposes of their broken wooden chairs or barbecue charcoal by throwing it over the neighbor's fence? Anywhere, but not in my backyard. In a similar fashion, Europe has been throwing some of its waste into somebody else's backyard for years. Over the last decade, the EU exported hundreds of millions of waste, going as far as Southeast Asia. Since 2004, the EU waste exports increased by 75%. Recipient countries cannot always adequately treat the waste they receive. As a result, landfilling, dumping, and open burning waste have dramatically increased with catastrophic effects on air, soil, rivers, and seas. Positive policy changes are happening both in the EU and the recipient countries. The EU is setting new rules on plastic waste shipment. In parallel, several countries are planning bans to stop waste-related abuses. However, if Europe aims to stop sending its waste abroad, can it take care of it by itself? First of all, waste needs to be reduced, and reuse and recycling must be boosted up quite a lot. But that's not enough. Waste generation is still on the rise in the world and in Europe. That is why sustainable waste management is so important. Today, Europe recycles around half of the total municipal solid waste it generates. The other half includes non-recyclables that can either be treated by waste-to-energy plants or buried in landfills. Waste-to-energy represents a further step in the circular economy chain. In a complementary way with recycling, waste-to-energy plants take care of non-recyclable waste and minimize landfills. In return, the plants recover energy and secondary raw materials and supply them to citizens and industries. Sending our waste far from site will never be a thoughtful approach for the environment. As we wouldn't dare to pollute the neighbor's garden with our waste, let's support sustainable choices that keep everyone's air, lands, and oceans clean.
Welcome back to our event on waste-to-energy plants. Now, if you have spent any time around the climate sphere in Brussels, you're sure to have come across the phrase climate neutrality. Europe has pledged to reach net zero emissions by mid-century. That means any emissions after that will need to be offset by another removal elsewhere in the economy. Carbon capture and storage technology could offer that type of removal. Our next debate looks at Europe's goal for climate neutrality and what role carbon capture could play in waste-to-energy in the future. To discuss this, I'm joined by Yves Tam, founder and managing director of Climate Principles, in the studio, and Yannick Berkus, carbon capture and storage director at Fortum Oslo Farm Online. Now, again, we will have our presentations and hopefully some time for questions afterwards. So first of all, Yves, let's start with your presentation. Can you tell us more about waste-to-energy and carbon capture and storage in European policy?
Thank you so much for the introduction, Kira. And it's a pleasure to be here to share my take on carbon capture and storage and how it can help to reduce the emissions from waste to energy sector. And as mentioned in the introduction, the background behind us is the climate neutrality target, and everything we are doing now should be with a view to how to achieve that. I had some slides, so maybe we'll start there. Exactly, beautiful. And I think we can already move on to the next one. So I'll just use this introduction to give a bit of a background on waste to energy and CCS and how the climate policy currently regulates all of that. So we have quite a bit of waste energy plants in Europe, and I think you got quite a good overview already in the previous presentations on waste energy as such. And currently, if you look at the EU's sectoral climate policies, then we have the EU emission trading system that covers 40% of emissions, and we have the effort sharing regulation that covers 60% of emissions. And currently, waste to energy falls under the effort sharing regulation and the part that this policy aims to do to achieve the climate targets. And of course, the recent Fit for 55 package is proposed to change this mix a bit because there will be a new emission trading system for buildings and transport that will take a good chunk of the effort sharing regulation emissions, let's say 2/3 of them, which means that what will be left under the effort sharing regulation is going to be a lot less, maybe around 20% of all emissions. There will be less to play around with. I wanted to, and maybe I should have started with a disclaimer that, obviously when we talk about waste incineration, and when I talk about it, I always have it in mind in the context of waste hierarchy, reuse, reduce, recycle. And but I saw that in the previous session you got an extensive overview on that, so everything I will say will be again against that background. And when we talk about carbon capture and storage, obviously this comes to play in the context of reducing emissions in this sector. Partly, hopefully the emissions from incineration will be reduced because we will be reusing more, we'll be recycling more. So that's one part. But we will not be able to reuse and recycle everything, I think, for a long time. And residual emissions are there, residual waste is there, and hence the emissions from waste generation will be there. And one very obvious solution to that is to capture those emissions and transport and store them in geological in geological solutions where they will be stored for thousands of years. Now, this is very location specific, though, and it will not be a solution to every single waste to energy plant. So having access to that carbon CO2 transport and storage network is going to be crucial for those plants that are considering using carbon capture and storage as the emission reduction or carbon removal solution. So that is something to bear in mind, that the location matters. And the other part is also the size of the plants. On very small plants, it's going to be more difficult to find that business case to apply carbon capture and storage. If we move on to the next slide, then I'll talk a bit on what we could do to improve the policy frameworks. One big thing that the stakeholders have been asking for a really long time now is to have a carbon price on the waste to energy emissions. And this obviously would be also extremely helpful when we talk about waste to energy with carbon capture and storage, because having that carbon price good, it's not going to be the only solution that makes CCS happen on waste energy plants, but it can definitely play a very big role in incentivizing deploying these new technologies. And so one solution is to include waste to energy under EU emission trading system. The current one, I'm not sure if these conversations are going on, but the other emission trading system for buildings and transports, there might also be a way to maybe include energy waste incineration with energy recovery under that, if the heat is used for commercial or residential buildings. So there are options out there, but it seems like we don't have a proposal yet on the table that specifically offers a solution. So we know that the co-decision process will be now ongoing with all these proposals under Fit for 55, and I think there's ample of opportunities to bring this topic up and try to make it happen. Another topic, very important, I understand here more in the next session, is including waste energy in sustainable finance taxonomy. Again, I know why it's not there yet. There are some carbon capture and storage applications that are taxonomy compliant and already within the scope. Waste to energy is not one of them, and it's a bit difficult, but we need to have a lot of perseverance to make it happen, because it's going to be crucial to secure those funding opportunities. And talking about funding, I think that's one of the big discussions that we have when we talk about achieving climate neutrality eventually. I always try to highlight that the funding in Europe is happening on two levels. One is the national level, and the other is on the EU level. So if you talk about waste to energy, especially the countries that have high emissions from waste to energy sector, it's important to highlight that in their national decarbonization strategies, foreseeing funding for different solutions to reduce emissions, and again, waste to energy and carbon capture and storage on it are something that can reduce emissions in quite a few countries. And in the EU context, Innovation Fund is obviously an important source, and I think you'll hear a bit more on at least one of the projects that have applied and have made it to the second round in the next presentation. So yes, we'll need funding to make it happen as well. And I'll stop here.
Brilliant, thank you, Eve. And Jannica, I think we can come online to you for your presentation. You have the floor.
Jannicke Gerner Bjerkås, I'm the CCS director in Fortum Oslo Varme. We are aiming to establish carbon capture and storage from our waste to energy plant in the city of Oslo. Next slide, please. Just briefly on our company. We are a district heating company where the main heat load is coming from our waste to energy plant. We're also providing district cooling and also utilizing heat from other sources where the excess heat would otherwise be lost. On the next slide, we can see a little bit more details about our specific projects. As I said, we're aiming to establish carbon capture, which, if everything works as we hope, we will be the world's first full-scale CCS project on a waste-to-energy plant. Our project is part of the Norwegian full-scale CCS project named Longship, after the Viking ships, where the goal is to establish a full and open value chain for carbon capture, transport, and permanent geological storage of the CO2 below the seabed in the North Sea. There are 2 capture projects in this CCS project, one from cement and then our project from waste to energy. Our goal is to establish to capture 400,000 tons of CO2 every year, which will be about 90% of the total emissions from this plant. And the specific advantage with waste to energy, which several of the other speakers have touched upon, is that about 50% of the CO2 emitted from these plants are biological CO2, which means that this CO2 stems from biomass, biogenic waste, and is thus a part of the natural CO2 cycle. So when we capture and store this CO2, we are in effect removing CO2 from the atmosphere. And this will be an important technology to help reaching the European and the global climate goals. We have been working with this project since 2015, maturing through feasibility, concept, and FEED studies. And we've also had the project externally quality assured from the Norwegian state. Our project is also important because it demonstrates how we can solve the challenges of transporting the CO2 from the plant to port when the emission point is not actually situated at port. We will solve this transport by using emission-free trucks, preferably electric trucks, and the distance is about 10 kilometers. We have tested our technology very thoroughly. We chose amine technology, which is the most mature technology today. And the technology had been proven on capture from coal power, from gas power. The change with this project is that we are working to reduce emissions from industrial emission points that don't really have any other solutions for reducing emissions. And we decided to build and operate a pilot to test the technology on the industrial flue gas from waste to energy. We had very good results, tested for 9 months with this pilot, and we had very low emissions, high capture rate, and stable operations. So we are quite confident that this plant will work very well also at full scale. On the next slide, this is a sketch of how we would like the future circular economy to look like, with carbon removal on the end solution for residual waste that we cannot recycle. And this has been introduced quite thoroughly today. So I will focus on the last step of this waste hierarchy and the fact that we need to keep the raw materials in the cycle, and we need to stop sending waste to landfills, which is the greatest methane emission source and the greatest climate contributor to climate warming from waste handling. And I would like to address a couple of the statements from Jannik Vak actually on this slide, because and I would like to emphasize that emissions monitoring is not limited from waste to energy. At our plant, we have continuous monitoring and very strict emissions limits. And we've also, in Norway, there has been conducted several soil studies as well on the proximity of the waste to energy plants, which proves that there is no impact on the local emissions and on contaminants of the soil. So I really don't recognize the statements from Jannik Vak on that matter. I would also like to see the studies that are actually showing that landfills is a better option for residual waste, because that is quite the opposite of all the studies and the facts that I've seen, that where landfills is the main problem for waste handling and the fact and the issue that we really need to address. And third, I think it's also worth discussing the issues regarding how to utilize the biofraction from mechanically sorted waste and the biofraction, because when it's mechanically sorted, the issue and the problem is to find use for this biofraction, because it's usually much more contaminated, much more heavy metals than with source sorting. So this is not a quick fix either with the MRBT. And fourth, I think it's also, and this was mentioned from the video just before this session, that one of the main issues that we're not discussing in this section is all the waste that is exported for other countries to solve the problems, which means that we don't have enough or too much waste to energy capacity. We have far too little to handle our own waste when we need to close down landfills. So adding this last step on the waste to energy plants means that we're not only reducing the emissions from fossil CO2, especially from the plastics, which is a problematic fraction to utilize and to recycle as well, and we need to work on that as well, has been mentioned. But we can also contribute to remove the biogenic CO2, which will be, as I mentioned, important to reach the climate goals. Very briefly on the last slide, I will give you a status of the project and the financing. Our project is fully matured through 2015 to 2020, and the Longship project reached the final investment decision in the Norwegian Parliament, and the state decided to fully support the transport and storage part of the project, which is called Northern Lights. What regards our project, we received conditional support, about 50% of what we need, CapEx support of 200 million euros, and OpEx support of about 100 million, split over 10 years of operation. And that's why we have applied to the Innovation Fund for some of the remaining funding. Our project has a few very strong advantages. The most important is that we are fully matured. We are shovel ready as soon as we have the financing in place, which we hope to have at the end of 2021. We will start right away. We are partly funded from the Norwegian state, in addition to the fact that the transport and storage part of the project is fully funded and already underway. Also, a large BECCS potential is crucial for this project to demonstrate CCS on waste to energy and be a pioneer on climate positive waste handling. This will be replicable to a lot of the other waste to energy plants in Europe. And if everything goes according to plan, we will have the project and the carbon capture plant up in operation at the end of 2025. Thank you.
Thank you both for your presentations, and yeah, I think it's amazing to see the practical implications after we've seen quite a lot of the theoretical. I would like to come back to you online. Could you just go through what are the benefits and what are the disadvantages of using this type of carbon capture and storage technology on waste to energy plants?
Well, I think the advantages are very clear. We are dealing with the CO2 emissions from this end-of-line solution for waste, which means that we're dealing both with the fossil emissions that we are counting on emission statistics, but that we're also actually contributing to carbon removal, which will in its turn will give room for dealing with the other emissions that are harder to reduce in the short term. So waste to energy can contribute to removing large amounts of CO2 from the atmosphere.
Some disadvantages?
Well, I don't really see any disadvantages because this is an important technology. It's a very effective climate measure. It's very important for cities to address their large emission points dealing with their waste from the cities. And as I mentioned, also the carbon removal part. Of course, the disadvantage, if you could call it that, is that technology is still costly and it takes a lot of space. But that's because this is early in the development. We need to see a volume of these plants to learn from these first demonstration projects and to develop the technology, reduce the footprint of these plants, to improve the energy efficiency and so on, and to have the same development as other early technology providers to reduce costs and hopefully more and more integrate it into and combine it with flue gas cleaning.
The same questions to you. What do you see as the benefits and what do you see as the disadvantages of this technology?
I take it's in the context of waste to energy,
Yes.
right? So benefits, obviously, there is a pressing need to decrease the emissions to the amount possible, and we've heard a lot already today in different presentations that there's also the potential for carbon removal when it comes to waste to energy. That, of course, depends how much can be achieved will depend on how much biogenic versus fossil waste specific waste to energy plant actually burns, and that's not always the same. It can be quite different among different countries and different plants. But yes, we need to drive down those emissions, and carbon capture and storage is clearly a solution to do that. Now, the challenge is that we need the transportation and storage network, and it's the same problem for the other industrial emitters in Europe. It's kind of a chicken and an egg problem. You would want to have a network in place so that you can make the decision to start capturing from your plants, but then you cannot really have a network in place unless there is CO2 being captured that you can then use that network to transport and store. And what we really, really need on the European level is to have the plan to have such network in place. Many stakeholders have been asking for European CCS strategy. I think that would be a good place, for example, where this kind of plan could be laid out, because if you look at how CCS is developing and the projects are developing in Europe, they're developing in clusters where industry is present. In some cases, there are waste to energy plants around, and you can then capture CO2 from all these different sources and use the common transportation and storage network. That really makes it a lot cheaper compared to, let's say, 10 or more years ago, when all the CCS applications that were planned were for one plant to have their own transportation and storage built out, which would make it much more expensive. So we would have this opportunity, but it's currently we don't have that plan yet, and that's a problem, and that makes it difficult.
So it's definitely a developing technology. Coming back to you online, you mentioned it's kind of scalable. How many waste to energy plants could we see this type of technology on, and what is the timeline and the cost for that?
Well, I think in Europe in total, we see there are more than 500 waste to energy plants. Of course, there are different sizes and different locations, as Eve has also touched upon on these plants, but a lot of them will have to and will need to look into CCS as a measure to reduce emissions from their operations. In Norway, we see that all the larger waste-to-energy plants have now started separate studies on CCUS. So I think this is this is a development that it's coming. It's going to be an important technology for the waste-to-energy sector to reduce the climate emissions from this process. But as Eve has also been clear on, we need to find solutions for the transport of CO2.
Be the type of cost for that level of scaling up?
Could you repeat the question, please?
What is the cost for that amount of scaling up?
Well, I would say that if we were to solely cover the cost of CCS by, for example, ETS price today, we would need to see a price of about 150 euros. But this is the early demonstration projects. So the cost will come down, and I'm sure we will also see the cost of emitting CO2 will have to rise. But for now, we are dependent on some sort of external funding, government funding, in addition to this, to the price of emitting CO2. And in the future, I think we will, actually in the very near future, I think we will see the bio content and the carbon removal market developing to be an important revenue stream for these projects. We see it today, large corporations are stating that they will go net zero, which also with historic emissions, which means that they will need to buy so-called CORCs, carbon removal certificates. And we see the prices already rising quite substantially on these private initiatives, market platforms. We know that the EU will come with a proposal for addressing these carbon removal certificates next year already. So this is definitely a market that will develop, and I think it will develop fast, and it will be an important contributor to develop these projects economically.
And Eve, coming back to you for a second, we've heard some environmental concerns about waste-to-energy plants over the course of today's event. Is waste-to-energy and carbon capture and storage enough to tackle that, or do you need more than carbon capture and storage to be able to maybe mitigate some of those other concerns?
Well, I have to be honest, I came here to talk about the carbon capture and storage part of things. But I think the biggest problem is the emissions and the need to reduce them, especially if you talk about in the context of the climate goals. So it does tackle the big parts of it. And I think we have other regulation in place to tackle other elements of possible negative effects that waste energy can have. So yes, I would say definitely. I haven't heard of another obvious already existing solution that you could apply on waste energy plants to bring its emissions very close to zero, or in some cases even to negative. So we definitely have to work towards it.
And Yannicka, I know you had some criticisms of some previous people and what they had said, so I want to come to you on this question. But I also want to bring up something which Eve mentioned earlier about a carbon capture storage plan, something from the Commission, maybe a carbon capture strategy from the Commission. Do you think that would be helpful for this type of innovation?
Definitely. I think we will need this kind of framework and legislation to lift these projects. Absolutely. And if I may come back to the question that you asked Eve as well, and that I commented on earlier, I think this is exactly the important point to make, is that I don't recognize that statement at all. In Norway, and I know it's the same in Scandinavia, and I believe there are very strict emissions limits in Europe in general. For these plants, very clear and very low emissions limits to local emissions, and we have continuous monitoring of the flue gas. And as I mentioned, we've also done, or the Norwegian government, the Norwegian authorities have done several soil studies as well, which has proven that there are no increased levels of local contamination to the local soil. So I really don't think this is an issue. And what we need to address now is better source sorting and better utilization of the resources that we should keep in the cycle, and then to add carbon capture and storage to deal with the climate emissions from this end-of-line solution.
And staying with you online, we've heard about the efforts to fund this from both the EU and from the national government. What more do you need from the EU and national states in order to help support this technology and grow it?
Well, I think a very important step will be when we see next year the suggested framework for carbon removal and the bio share of the carbon capture part. So that will be an important step to establish markets and marketplaces for these carbon removal certificates, and to find future revenue streams. And then we've also mentioned the transport solutions for the CO2, which will be important to connect these emission points to established transport and storage solutions, such as Northern Lights, which is an open-end storage reservoir for other emission points to connect to as well.
Thank you. And we're beginning to round up this session. So if I could ask you both for your takeaways from this event. Eve, let's start with you. What are your key takeaways from this?
I'd say that for waste energy, carbon capture and storage is definitely a solution, and we need to work towards deploying it widely in Europe where it's possible. To make it happen, we do need a decent carbon price to cover waste to energy and carbon capture and storage, which currently we don't have. So, but we, as I said, we have options where it could be included. So I hope there will be serious discussions around it. And I mean, we have to bear in mind that it might not be feasible in every single, especially very small plants, and we'll need to think then how to tackle those emissions as well. So it is a solution. It might not be a solution for every single plant, but it's definitely, it can make a major difference in this sector and driving down the emissions and potentially generating carbon removal.
And Janneke, coming to you online, what are your takeaways from today's event?
Well, to build on Eve's excellent bullet points, I would say that yes, CCS for waste to energy will be an important technology to deal with the climate emissions in the future. For smaller emission points, I think also CCU might be a contributor to find a way to utilize these smaller amounts of CO2 more locally. And second, as I have mentioned several times, the establishing of framework and legislation for carbon removal and the BECCS part of this projects will be important to find future revenue streams in addition to the carbon price of the fossil emissions. And third and last, I think this is also an important technology and an important way for cities to reduce their emissions, to reduce emissions from the large emission points of the waste handling structure in cities, and to establish sustainable waste handling.
Brilliant. Thank you so much, both of you, for joining us. Up next, we have our final debate, our panel discussion on waste-to-energy plants in the EU Sustainable Finance Taxonomy. This will have a Q&A option, so please send in your Q&A questions using the function, hopefully, which is in front of you. We'll try and get through as many of those as possible. Now, while you think up your questions, we have another 2 videos for you to watch. The first is all about sustainable mobility, waste to hydrogen, road construction with minerals recovered, and aluminium recovery. The second looks at exactly what we've just been talking about, the integration of carbon capture and storage in waste to energy plants. So you can go away and watch those, and we will be back in a few minutes.
If I told you that Belgian and Danish streets are filled with waste, would you believe that? Yes, this is true, but not the way you imagine it. Belgium and Denmark treat their non-recyclable waste in waste-to-energy plants. These plants recover energy and secondary raw materials, including minerals that are used to build roads at a later time. This way, non-recyclable waste ends up in the streets, reducing the need to exploit virgin materials. Numerous other metals are recovered from the bottom ash: copper, iron, aluminum, steel. But how is this process linked with the mobility sector? In the Netherlands and France, the aluminum recovered from non-recyclable waste is used in automotive casting manufacturing. What about vehicles powered by non-recyclable waste? Waste-to-energy plants can generate hydrogen by converting part of the recovered electricity with an electrolyser. Wuppertal's waste-to-energy plant, for instance, already powers 10 hydrogen buses. This saves the city up to 700 tons of CO2 per year. From the construction of roads and cars up to the generation of hydrogen, waste-to-energy plants are powerful allies to move towards greener transports. And that's how the journey of our non-recyclable waste goes hand in hand with the European plan to reach a more sustainable mobility.
Today's mariners are still in awe of the Vikings' sailing capabilities, navigating across the deepest seas to new far-off lands. With their long, sleek, and narrow vessels, the Longships, Vikings' very own groundbreaking invention resulting from years of experiments and hard teamwork. Fast forward millennia to the sequel of Longships, the Norwegians are now placing great emphasis on testing a game-changing technology and taking it to European lands and seas. This time, it shall help Norway address the biggest challenge of modern times: climate change. As Norway's current objective is to reduce at least 50% of its GHG emissions by 2030, a Longship may come in handy to accomplish this target. As part of this strategy, the Norwegians launched in 2020 an ambitious project to capture and store CO2 in energy-intensive industries, naming it Longships, after their forefathers' notorious vessels. The feasibility of the plan has been tested by a pilot project carried out at a waste-to-energy plant, which is treating Oslo's non-recyclable waste. There, the carbon capture efficiency has proven to have a 90+% capture rate, meaning that the waste-to-energy plant will be able to capture 400,000 tons of CO2 emissions every year, thus preventing its release into the atmosphere. Oslo has set itself an ambitious climate roadmap, reducing 95% of emissions by 2030, compared to 1990 levels. Waste management is on the list of activities Oslo is prioritizing to successfully attain its GHG emissions reduction plan. The CCS project shows how waste-to-energy can be part of this strategy by treating non-recyclable waste with a view of carbon neutrality. Scaling these technologies to the entire European waste sector would help the EU pursue its climate neutral ambitions too.
If I told you that Belgian and Danish streets are filled with waste, would you believe that? Yes, this is true, but not the way you imagine it. Belgium and Denmark treat their non-recyclable waste in waste-to-energy plants. These plants recover energy and secondary raw materials, including minerals that are used to build roads at a later time. This way, non-recyclable waste ends up in the streets, reducing the need to exploit virgin materials. Numerous other metals are recovered from the bottom ash: copper, iron, aluminum, steel. But how is this process linked with the mobility sector? In the Netherlands and France, the aluminum recovered from non-recyclable waste is used in automotive casting manufacturing. What about vehicles powered by non-recyclable waste? Waste-to-energy plants can generate hydrogen by converting part of the recovered electricity with an electrolyser. Wuppertal's waste-to-energy plant, for instance, already powers 10 hydrogen buses. This saves the city up to 700 tons of CO2 per year. From the construction of roads and cars, up to the generation of hydrogen, waste-to-energy plants are powerful allies to move towards greener transports. And that's how the journey of our non-recyclable waste goes hand in hand with the European plan to reach a more sustainable mobility.
Today's mariners are still in awe of the Vikings' sailing capabilities, navigating across the deepest seas to new far-off lands with their long, sleek, and narrow vessels, the Longships, Vikings' very own groundbreaking invention resulting from years of experiments and hard teamwork. Fast forward millennia to the sequel of Longships, the Norwegians are now placing great emphasis on testing a game-changing technology and taking it to European lands and seas. This time, it shall help Norway address the biggest challenge of modern times: climate change. As Norway's current objective is to reduce at least 50% of its GHG emissions by 2030, a Longship may come in handy to accomplish this target. As part of this strategy, the Norwegians launched in 2020 an ambitious project to capture and store CO2 in energy-intensive industries, naming it Longships, after their forefathers' notorious vessels. The feasibility of the plan has been tested by a pilot project carried out at a waste-to-energy plant, which is treating Oslo's non-recyclable waste. There, the carbon capture efficiency has proven to have a 90+% capture rate, meaning that the waste-to-energy plant will be able to capture 400,000 tons of CO2 emissions every year, thus preventing its release into the atmosphere. Oslo has set itself an ambitious climate roadmap, reducing 95% of emissions by 2030, compared to 1990 levels. Waste management is on the list of activities Oslo is prioritizing to successfully attain its GHG emissions reduction plan. The CCS project shows how waste-to-energy can be part of this strategy by treating non-recyclable waste with a view of carbon neutrality. Scaling these technologies to the entire European waste sector would help the EU pursue its climate neutral ambitions too.
If I told you that Belgian and Danish streets are filled with waste, would you believe that? Yes, this is true, but not the way you imagine it. Belgium and Denmark treat their non-recyclable waste in waste-to-energy plants. These plants recover energy and secondary raw materials, including minerals that are used to build roads at a later time. This way, non-recyclable waste ends up in the streets, reducing the need to exploit virgin materials. Numerous other metals are recovered from the bottom ash: copper, iron, aluminum, steel. But how is this process linked with the mobility sector? In the Netherlands and France, the aluminum recovered from non-recyclable waste is used in automotive casting manufacturing. What about vehicles powered by non-recyclable waste? Waste-to-energy plants can generate hydrogen by converting part of the recovered electricity with an electrolyser. Wuppertal's waste-to-energy plant, for instance, already powers 10 hydrogen buses. This saves the city up to 700 tons of CO2 per year. From the construction of roads and cars up to the generation of hydrogen, waste-to-energy plants are powerful allies to move towards greener transports. And that's how the journey of our non-recyclable waste goes hand in hand with the European plan to reach a more sustainable mobility.
Today's mariners are still in awe of the Vikings' sailing capabilities, navigating across the deepest seas to new far-off lands. With their long, sleek, and narrow vessels, the Longships, Vikings' very own groundbreaking invention resulting from years of experiments and hard teamwork. Fast forward millennia to the sequel of Longships, the Norwegians are now placing great emphasis on testing a game-changing technology and taking it to European lands and seas. This time, it shall help Norway address the biggest challenge of modern times: climate change. As Norway's current objective is to reduce at least 50% of its GHG emissions by 2030, a Longship may come in handy to accomplish this target. As part of this strategy, the Norwegians launched in 2020 an ambitious project to capture and store CO2 in energy-intensive industries, naming it Longships after their forefathers' notorious vessels. The feasibility of the plan has been tested by a pilot project carried out at a waste-to-energy plant, which is treating Oslo's non-recyclable waste. There, the carbon capture efficiency has proven to have a 90+% capture rate, meaning that the waste-to-energy plant will be able to capture 400,000 tons of CO2 emissions every year, thus preventing its release into the atmosphere. Oslo has set itself an ambitious climate roadmap, reducing 95% of emissions by 2030, compared to 1990 levels. Waste management is on the list of activities Oslo is prioritizing to successfully attain its GHG emissions reduction plan. The CCS project shows how waste-to-energy can be part of this strategy by treating non-recyclable waste with a view of carbon neutrality. Scaling these technologies to the entire European waste sector would help the EU pursue its climate-neutral ambitions too.
Welcome back to our event on waste-to-energy plants. We're now entering the final leg of today's debate, looking at the role of non-recyclable waste in the EU taxonomy. Now, EU taxonomy is quite the buzzword in the Brussels bubble. The Sustainable Finance Taxonomy is the European Commission's list of green investments, what it considers climate-friendly investments. But there are concerns from the industry that waste-to-energy is not mentioned in the delegated acts, which lay out what investments in the European Commission sees as sustainable. They also argue that the treatment of non-residual waste is only partially explored in these. So, to discuss the representation, I'm joined by Patrick Clarence once more, ESWET Secretary General, Valérie Pleinmesson, the Secretary General of the European Waste Management Association, and Jonas Helseth, the Director of the NGO Bologna Europa. Now, we can start with a brief introduction from all of you. Patrick, what is your take on this subject?
Yes, thanks for asking this important question, actually. Actually, this goes down to the role of waste to energy. in the society and therefore then in the taxonomy. And if you look at waste to energy, you see that even if, as we heard before, the aim is to reduce residual waste by half in the next 8 years, which is quite a feat and quite a challenge, knowing that the waste generation in Europe increased in the last 5 years in a row, where we have statistics, so from 15 to 19, it didn't stop to increase, so that will be quite a feat. But we should go forward, separate, reduce the waste, and go in this direction. There's no other choice. But then to say that the waste vanishes makes for me no sense. Some parts of this waste to energy or the waste treatment, like hazardous co-incineration in cement kilns or other ways, are treated in the taxonomy. But the most important one, which has a real chance of reducing emissions, and we heard this, methane emissions from landfill and so on, it was clearly stated, is not treated in there. So for me, there's something missing, and knowing that the technical expert group asked the Sustainable Platform to look into the waste to energy topic, I feel it should be taken up and that the criteria should be developed.
Thank you. And I'm sure we'll dive much deeper into that in a moment. But Valerie, for the moment, what is your take on the topic?
If I may add something to what Patrick says, the more recycling we are going to do, and this is what we wish to do, the more quality recycling we need to do, and that is what we wish to do, the more residues you have as well. So the difference is the residues. So as Patrick says, whatever we wish, we will not avoid residues. And the taxonomy needs to tackle the fate of the residues in order to have them treated in a best way. Having said that, the taxonomy cannot ignore as well the hierarchy, simply said, and cannot ignore that to have a circular economy, you need to have complement which are indispensable to the other higher treatment steps. Not only complementary, but indispensable. If you don't have outlets of recycling facilities or recovery facilities for treating the residues, then those facilities are in trouble, are in difficulty. So it's urgently needed that residual waste treatment is not ignored in the taxonomy.
So a missing link in a way.
A missing link, yes. And for this treatment, waste to energy is the key, has the key role.
And Jonas, finally coming to you for your view on this. What do you think of this topic?
So maybe, thank you, and maybe for a quick background first, for those who don't know Bellona, an international environmental NGO founded in Oslo, Norway. And I think it's helpful with a bit of background on that because we've heard a lot about Oslo today in the conversation and what's happening there. We actually were at the start of that journey that Oslo's been making. And I think it's important to understand why that is. We don't really work on waste so much as we work on climate. Waste is part of what we do. And Oslo was, of course, one of the cities that said early on they want to be a climate leader. They want to go net zero. And we worked a lot with Oslo to come to the conclusion about how they can actually do that and what are the main sources of emissions. And one of those, of course, major sources for most cities will be waste incineration. And what Oslo wanted to do, and I think that's also important here, is changing the timeline. Everyone in Europe is now talking about net zero in 2050, but Oslo wanted to go for net zero in 2030. And we see a lot of cities, and I think that's all over the world, taking leadership in the climate debate and saying, you know, where governments are not willing to go because of various constraints, cities can take lead. We see that in America, we see that I think in most big cities around the world, they want to step up and fill the gap that governments are leaving. So we saw in Oslo found that waste incineration is a major source of emissions. We work toward, also a world where we recycle everything. And I think that still has to be what we're striving toward. And it should always be starting with reuse, recycling, before we get to anything else. But what we focus on is the climate emergency. And in that situation, we don't have 30 years, we don't have 20 years to deal with emissions. We need to do something about them in this decade. And that's why Oslo has that CCS project. We started working with that with the city of Oslo before Fortum as a company bought the waste incinerator. We're happy to see Fortum bringing that onward, but we need to see other cities stepping up. We see that in other cities in Europe, but also elsewhere. we were just contacted by New York City representatives who want to look into something similar for their waste incinerators, and in the Netherlands we see a lot of development. So for us, this is about the climate emergency and about the fact that even if you believe that we don't have residual waste in 2050, we're going to have it in the next decade, and that is the timeline we have to act.
Thank you. And my first question follows on from what you've been saying. Patrick, maybe let's start with you. What will be the need for residual waste treatment in the coming years? Will it increase? Will it decrease? And is there an investment gap that needs to be filled when it comes to things like supporting these waste-to-energy plants and maybe the taxonomy?
Maybe it's a bit too technical, but actually all the statistics we're looking at in Europe is municipal solid waste. But municipal solid waste is only 10% of the total waste which we generate in the EU. So we're talking about 10% of all the waste we produce. Okay, some of this waste is construction waste, some is mining waste, but still it leaves a significant portion which is CNI, so commercial industrial waste, out of this whole picture. Also, this cutting in 50% in 8 years leaves all the rest out of the pictures, only municipal solid waste. So we need to treat this waste, and we need to continue with separate collection, recycling as much as possible, but then we need to get the residual waste streams which we cannot recycle treated in a sustainable way, where we heard the whole day how this can be done and how it can go carbon negative. So by not including waste to energy taxonomy, you will either manage to push the waste out of Europe because the facilities will not be there to treat this waste. And Ella mentioned before that we don't have all the capacities we need today to treat the residual waste. I'm talking about the residual waste if you see what's coming up. And on the other side, we see that the member states which landfill, and some member states landfill still 80% of the waste, 80%. They for sure need to go to recycling and separate collection, but they have a huge need for waste to energy capacities in this integrated waste treatment. And that's what we're looking at. So you punish these countries and you don't address the topic by putting them under the carpet. It's not helping.
So in a way, the taxonomy is always almost ahead of itself in getting rid of this, because it is leaving this gap when it comes to what many countries need to use to get rid of landfill.
I've got a question. So you followed the news recently. We saw that we have a huge increase in gas prices, in electricity prices, going through the roof. And a lot of people blame, when you read the news, this to the fact that we don't have enough generation capacity, not enough dispatchable generation capacity. And this is one of the reasons why you have this price increasing. And now a lot of people ask, oh, did we not put the order on the wrong way? Shouldn't we not first put the renewable generation, the storage, the grids, and build this all up, and then only stop the dispatchable backup power, which is mostly based on fossil fuels? And on the waste treatment, you can ask yourself the same. Should we prohibit proven residual waste treatment today, cut it off, and then see what happens? Or should we not more put in place the other treatment, an MRBT? We heard it before, but we did not really see this happening. I don't know where's one MRBT plant. In both publications from the NGOs, I read a lot about we will do this, we project this will happen. But I didn't see it happening today. While the residual waste is there today, the residual waste is landfill today, and we need absolutely to treat it in a sustainable way, and not putting it under the carpet for the next generation to dig it out of a hole because it will pollute the groundwater or because the resources will be needed. So we need to act now, and waste to energy is needed for this in an integrated way. I repeat it, and therefore not addressing it, for me, is lacking seriousness of the policymakers.
Thank you. And yes, I know you wanted to come in on this. Is there a gap in the taxonomy?
So before I get to that, I think it's important to say that I still haven't seen a study that substantiates the, if you look at a 10-year timeline, a 20-year timeline, the need for additional waste incinerator capacity. So it'd be good to see those numbers if you have them. Now to the taxonomy, and that's back to your question, I think earlier, that is the taxonomy getting rid of waste incinerators? I think that's the wrong framing, and I think it's really important to get that right, because it reminds me very much of the debate about should gas be in the taxonomy, because it's a transition fuel. First of all, back to what I said, if we don't make the right decisions now, we're locked in with the wrong stuff 30 years from now. So I think there is no such transition space, but that's a different debate. The point is that a lot of people talk about whether gas is in taxonomy or not as something that implies that gas investments will be banned if they are not in the taxonomy. And the taxonomy is not about banning stuff. It is about creating a gold standard for what is to be seen as a sustainable investment. And that has to be the basis of anything that is included in the taxonomy. Not being in the taxonomy does not mean that it's illegal in the European Union to make an investment into something. So I think that's really important to get across, because we've seen what Vice President Dombrovskis said. He had a written response to a parliamentary question this summer about whether waste incinerators should be in the taxonomy. And the reference, of course, was to the do no significant harms principle, and a document that the Commission put out as a guideline document for the recovery funds for the member states this summer. And not surprisingly, there was a clear reference there to, in the context of new waste incinerator capacity, that this would be damaging the targets for reuse and recycling in the European Union. So, you know, I think back to the point about numbers, we need to see a substantiation of why there is an apparent need for building new capacity. I haven't seen that. But I think it's very fair to say that if the targets for recycling and reuse mean anything, then, you know, there is a strong case to be made for not putting new capacity in place. However, what from my perspective is missing in the taxonomy when it comes to waste incinerator is the same thing as perhaps for gas. There should not be under any circumstances anything new built without CCS as a starting point, because we are in a climate emergency. If you build a gas plant like Belgium is now planning, well, that's a decision to be made, but not if there is no plan for CCS. If you build a gas plant, which is Germany is planning to do, to replace coal with the current coalition agreement discussions, it should not be allowed without CCS, and I think the same is true for waste incinerators. You shouldn't be allowed to build one, but we could have a discussion about should an investment into CCS on the existing capacity be a sustainable investment. I think that's a different case entirely.
Sorry for taking the floor. To reply to what you said, if you look at CWEP, what CWEP did, they made a so-called circular calculation tool. Go on the web page, play with this tool, and you will see the need for residual waste treatment.
And I have another remark. This would have my first remark, but the second remark is that non-being taxonomy eligible is not only a matter of accessing green finance. It will be a matter of being politely correct for any circumstances of the business life, of the waste management chain, and it will be also a very important key element in many regulations. So if you're not taxonomy eligible, you are not well perceived, you are not well treated, you are not positively treated in other regulations. I can give one example, which is the state aid rules. I can give another example, which is the resilience and recovery plans. So many regulatory tools will be taken based on the taxonomy, which is probably a bit of exaggerated, but it is going to be this way. This is another reason why we pay attention to it.
Certainly. And I mean, would you, Valerie, want to see waste to energy plants seen as a transition fuel or a transitionary technology? Or would you like to see it fully included?
It is not a transition fuel. It is, I mean, waste to energy plant produce heat and electricity, but not because it's a transition fuel, because it's a waste treatment that is crucial for the circular economy to happen, and that is a crucial step in the waste management chain. We operate the whole waste management chain, from collection to preparation for recycling and recovery, energy recovery, final disposal, hazardous, non-hazardous, municipal, industrial and commercial waste. So in all those areas, there is a need to consider the integrated chain of waste management, and waste to energy belongs to that. And it's a positive one because it uses the energy resource, the energy that is embedded in the waste. If it's no more needed in 20, 15 years, then we'll see. There will not be a lock-in effect. Waste will not go again to incinerators if there is no need for this. They will go where they have to go. If there is zero waste, then we'll be happy. I'm not sure that it will happen. Residual waste have to be treated. This is the reason why.
Is there an argument that you could actually include waste to energy, as Jonas says, when it has carbon capture and storage, and then that would push more funding towards a more greener waste to energy plant?
We would see three conditions for taxonomy eligibility for waste to energy, as far as FEAD is concerned, the Private Waste Management Association. But I don't think that other members of other associations would disagree with that. First, the plants, the facilities to be financed through green finance and taxonomy eligible should be in countries where there is a waste management plan. This is by law, but it is not properly enforced. And we think it is a very good tool to avoid overcapacities or to put capacities where they are needed. Mid, long-term strategy by the public authorities with the help then of private investment if needed. The second criterion for eligibility would be ensure that there is a selective collection scheme, separate collection waste or sorting out. Make sure that it is residual waste. And we are ready to engage ourselves in the fact that there will be a certificate. I mean, you show that this is existing. And the third criterion would be to check whether CCS, CCU is feasible. Because the answer is not always yes, but in case it is yes, it has to be implemented, it has to be put in place. That would be the three criteria.
And Patrick, do you see similar criteria? Is there anything you would add to that or disagree with?
Support this. I think it makes only sense to use waste to energy in an integrated waste management. That's clearly the case, and that's what we support from the beginning. And this is reflected in these three criteria, but it should obviously reply to the question of your fuel also. Will it be transitional fuel use or something? The answer is very easy. If you believe that you can recycle every product eternally, then you have no residual waste and you need no residual waste treatment. If you believe that you cannot recycle every product eternally, then you need to deal with the residual waste. That's as simple. Life is a matter of choices. For waste, it's exactly the same. It's all about choices, what you do with it. Because the pollutants are not going away if you make MRBT or MBT. It is in the waste, which you and me, we all produce. We throw the stuff away, and it is there. And what happens with the heavy metals? Either we put them into the ground or we treat them, as I said before by Tom, they are separated, they will not go into the environment. So these are the questions you need to apply. It's all about choices. You cannot wish something and hope it will happen.
So it's actually addressing the issue which we're already looking at with the waste we're producing. Jonas, would you support waste to energy plants being supported in the taxonomy if they had carbon capture and storage?
It's not really us that Patrick and others would need to convince when it comes to the case for new capacity. I think that that is a case to be made, not least toward the Commission, where I just referred to the answer from Vice President Dombrovskis and how that fits with the circular economy targets, the recycling, reuse targets. Now, I also don't really see how one can make the case that waste incinerators, new or old, have a place in the circular economy. However, as I said, the climate emergency is why I'm here, and that is what we need to address. So for me, under any circumstances, nothing new can be built that doesn't have a plan to be compliant with net zero. I think still I would like to see more engagement from the sector itself to deal with emissions, what we see in Oslo, but we need to see that elsewhere. And I mentioned some other places where we see that engagement. We need to see that across the sector. What is a plan to be compliant with net zero on the existing installations before we even start thinking about building something new? And of course, you can always make the case that, a waste incinerator is better than a landfill from a climate perspective. It's true, and for other perspectives too. But it is not something that should be branded as a green investment, because it's not. It is not a sustainable investment unless there is a climate plan, unless there's a plan to make sure that it doesn't undermine the targets that Vice President Dombrovskis referred to.
And Patrick, could I just get you to say maybe how many more waste to energy plants does Europe need? We've heard that some member states maybe have more landfill and that waste to energy might be useful for them. And so how many do these member states need, and would the funding, how much funding would be needed for that?
First, I would like to reply to what you said before about the circularity of waste to energy. In waste treatment and in a lot of industries, we don't see a fundamental change in 4 years. It is roughly the direction. And 4 years ago, the Commission made a communication on the role of waste to energy in the circular economy. 4 years ago. So it's not changing. So waste to energy has the role to play in the circular economy. The Commission acknowledged this. The Commission defined also the recycling methods, how you evaluate the recycling of metal from waste to energy plant and how they count towards your recycling targets. We have also tools for this to really quantify how much metal we do recycle in these plants, and we contribute to the circularity of the economy. So this is a point which I think has been discussed at least 4 years ago, has been clarified. So I see the role of waste energy in this. That's the first point. The second point, and I'm very sorry I can't reply to your question, I will not give you a number. I cannot give you a number because it's coming back to what we said before. The faster you can develop alternative treatment methods or do more recycling, the less you will need waste to energy. Waste to energy has one role: to treat residual waste and avoid that it's landfilled. That's the only role it has. And by doing so, it is recycling metals, energy, recovering energy, and so on and so on. So the number depends on your question on how much waste you want to ship around, how much residual waste exists after recycling, what hygienization needs are if another COVID wave will come. We will need to take care of all this masks and all the plastic stuff we have done, which nobody wants to recycle the COVID virus or other viruses again into a new product. So that's something which is not done. So you have a hygienization point, and all these parameters will define the number of plants. But it must be looked at what you said in an integrated waste management. It is not, we should never build a plant just to build a plant in order to be there. We need to do what we are striving to do: circularity of economy, resource efficiency, and avoiding to pollute our planet. That's what we should try to do.
Again, maybe in member states, especially where there are very low recycling rates and very high landfilling rates, the way to make a big shift is, of course, to have more recycling facilities and more waste-to-energy facilities. And if it's not taxonomy eligible, then not only the green finance, but any kind of bank or financial partner will avoid to lend money because they are also green tagged in their reports. Companies are also green tagged reporting. They make non-financial reporting. And all in all, even if it's not only about the green activities, any legal activity which is not taxonomy eligible will be in trouble for its development. This is why we think that having strong criteria makes this development virtuous, and having no criteria makes this development not happening, which will be a problem.
For me, that sounds like an argument that everything in the economy should be in the taxonomy, even if it's not net zero compliance, everything that we want to be able to invest in. And there are some things that, of course, will have a shorter timeline, some things will have a longer timeline. But I don't think we can make that argument, because then the taxonomy is at some point meaningless. Wouldn't you agree?
Establishes criteria, so quality criteria. So we are not saying all waste-to-energy plants needs to be eligible. R1, of course, and a certain, the criteria I mentioned, to make sure it is only residual waste, because those need outlets. And if they don't have outlets, by law, recycling facilities has to be closed. If you have residues, you don't put them in your yard. You have to make sure there is an outlet for them. We see some Belgian members of FEAL being obliged to look for outlets not in Belgium for landfilling, and that was the case of that, going to France for final residues because they had no outlets immediately available. And that can be the other way around. And we see that, so we have no big figures for that, but it's case by case, and it makes your life as a recycler impossible if you don't have outlets.
I suppose that is the question here. What happens if it's not in the taxonomy? What are going to be the real world impacts of losing out on this kind of investment and this kind of sustainable tag? Patrick, please.
So what is the impact? First of all, we're coming back to the first question. Is it needed for net zero carbon? And I support you on this. This should be our aim, driving our activities, because we want to go to net zero carbon. And do you need waste to energy in there, in an integrated waste treatment? We believe yes. If others believe no, they should tell us why they don't believe this and what they want to do with the residual waste. So then the question about what will happen. We had Valerie explaining it quite clearly. Pension funds want to go sustainable. Companies need to show that they're sustainable. Municipalities want to go sustainable. So we're coming to a point where the only way to assess it if it's sustainable by looking either at some kind of green analyst to analyze and tag and rate the companies, or we're looking at tools, government tools like the taxonomy, to know if it's taxonomy compatible, then therefore if it's sustainable. And if you're not in it, you will not be treated as a sustainable technology. And again, you come back. Are we needed as residual waste treatment by 2050, 2030 maybe in Norway? Where is the role? And nobody until now showed me, beside by promises on PowerPoints, how we can get rid of what we have for the moment. And that's a real issue for me.
The waste management plans at national level are also one of the key points to be assessed, whether or not they exist. If they're not existing, that's not appropriate. If they're existing, then they will do the job. They will foresee what is needed.
But excuse me, these are waste management plans, as you say, and I think back to the 2030 point in Oslo. This, for me, again, is a climate question. Oslo is not aiming to be zero waste by 2030, but is aiming to be net zero emissions by 2030. And so, again, when we're having this discussion, I miss that engagements from the sector itself to say what is our plan for being net zero with our current installations. And I think you would also find that it's easier to make the case for relevance in the future and for relevance in taxonomy if that plan was existing. I don't see that plan anywhere at the moment.
What we do now in ESWET, we're providing the technologies, and in there we're looking at 2 points. And we started our work, that the work groups we have. One is on hydrogen, as was mentioned before, and the other on CCS. And we see both of them are needed because your trucks need to drive on something when you go. It could be electric, obviously, but if they're heavy trucks, I think you need some synthetic fuels or some hydrogen, a bit like this. So the plans for us is to allow the waste to energy plants, if they are needed, which we believe, because I don't believe in net zero waste. I believe in net zero carbon, but not in zero waste in 2050. I don't think we will be able to recycle everything and have no residual waste.
And can I come in with some questions from the audience? So Jana Sheldek says, in Norway, even in areas with source sortings, still have a lot of recyclable waste ending up in mixed waste, including food waste, plastic waste, etc. And then that goes to incineration. What can we do to improve source sorting to achieve better sorting at home? Maybe Patrick, you want to take this one first?
This is the most important thing to do. Source separation, sorting at home, making sure that the one pollutant is not contaminating a recyclable product. Because at the end, if you have a chemical product which is ending up in the food waste, and you make a compost with the food waste, or with wood, and you make a compost, then it ends up, the same pollutant ends up on the fields, and it's helping no one, so we don't want to have this. So if you separate this out, and you make a separate collection where you have cleaner waste streams, obviously you have a better product to start with. So that's the most important part. But once it is mixed, then it depends on the environmental impact, if it's better to clean these plastics out of the other waste around it and use chemicals or whatever you need, solvents to do this, or if it's better to then incinerate. But then you should have an environmental footprint, looking what is better for the environment, you make a life cycle analysis, and you understand what you should do.
And Jonas, what's your view on that?
So, excuse me, I think just maybe back to a former point first, because I think, again, when you look at the Oslo project, and I think, our organization, we were 20 years ago saying there is no such thing as waste, it is a resource. And we still believe that has to be the direction, but we have to be able to have two thoughts in our head at the same time. So deal with climate emergency, and then at the same time try to reduce waste as much as we can every year, and make sure that we have realistic targets, that we have strict targets that force that development. And I think there might be a lot of nuances between the situation in each member state, and we have to recognize that. But at the end of the day, the targets for every sector of society is a net zero target, which means in the past, every sector might have hoped to be in a situation where they could get away with, carving out a few percents for themselves to be on the inside. But I think that is no longer a realistic hope for any sector, and that's why the pressure is on. And I would like to just say again, I think we need to see a plan, and we need to see a plan from the sector itself, and it's not on us to make that plan.
And a lot of this comes down to waste treatment. We have a question from Charlie Melio, talking about MRBT, so material recovery biological treatment, and we've heard a bit about that today. Valerie, maybe I'll come to you with this question. How efficient can sorting residual waste be when it's already been sorted at home in MRBT alternative? Isn't the improved sorting at source a better solution? So how do they compare against each other?
First problem is we haven't seen MRBT working at a large scale. When we see it and if it works, we will consider it, but it's not industry proven. Then another remark I'd like to do is our colleagues from ESWET did a very good study Patrick invited you to look at, and there are estimates on the savings of CO2 up until 2030, because when you use the energy content of the waste, you save on fossil fuel. I know that one day every energy production will be from renewables, but it's not yet. So each single ton you haven't emitted is always a gain. And then the second thing is that also in relation with this study, we should not look at every installation's emissions. We should look at the sector as a whole, waste management sector. We're going to issue together with other partners a study trying and show how much the waste management sector can avoid CO2 emissions, but not a sector and another sector, not collection apart from recycling, apart from waste to energy, apart from disposing of, all together. And then we sum it up, and then we see. Of course, the main positive contributions come from recycling, but it's a whole thing together because it's integrated.
Question to that, if that's okay. Yeah. So just because I think that's what you said about not looking at each plant, and I understand where you come from that, of course. But just on the point of the criteria that you listed earlier for new plants that you would like to see in taxonomy.
You're right. For the taxonomy, each plant will show if they respect the criteria. But I mean, generally speaking, if you consider the emissions of waste management as an integrated sector, then for the implementation of the taxonomy, it will be installation by installation. But don't forget that this is a needed installation.
And when it comes scheme play, waste to energy currently isn't covered by it. Do you think that if waste to energy was included in such a scheme, it would boost carbon capture and storage technology? Patrick, maybe to start with you.
Yes. So first about the plan to get CO2 neutral. A plant today emits 60% of CO2 from biogenic origin. So as was said before by Tom. So it leaves 40% of our emissions where we need to abate if you want to get out of this. We see that we recover metals, bottom ashes. We see that we divert this waste which will go to landfill. So today, if you calculate all this, either we are carbon neutral or near to carbon neutral, because the metals, you need to dig it out. If you count the metal, a ton of metal, to be produced. So there are, again, numbers and studies which we did in this direction. And when you include all the added value we have, we are quite advanced compared to other technologies, other sectors. And very fast or you want to reply to this now, maybe?
One quick reply to the point about the metals, because I think that's important. I think that we can't really get into a situation where you can offset emissions in that way. It doesn't work. I mean, the metal digging sector has to account for their own emissions. So, everyone, if we're talking about net zero, the target for society, you can't have. For me, this is a bit like what we hear sometimes from the chemical industry, that we produce insulation, so we reduce emissions in houses.
Accepted your point. So we're not neutral, but we're already quite near, and we have to get there. The point is a valid point. To reply to the CCS part, to the EU ETS part. So if waste to energy should be in the ETS, then we should to make sure, first of all, that you're not creating a perverse incentive and pushing some waste out of this capture or the ETS stream, meaning you need and also landfills and other waste treatments to be included. It cannot be I take just one and I don't put the rest. So it must be, everything must be included. It's very important. The second point is it better for the environment or not? All the discussions we had until now did not have a proper impact assessment to know if it's better or not better. I think at the end, for sure, if we have CCS, we can live with both. We get an added credits because we get negative where we can sell these and there are revenue streams with that. So it's not a clear cut we want to be out, we want to be in, but it must be done correctly. And basically this means that this CCS topic must be pushed, supported, implemented, because a plant can abate CO2. And we're coming back to this argument which is often used, the chicken and egg argument. Oh, there's no infrastructure to transfer the CO2, so why should we capture the CO2? No, we need to push both in parallel and build it up, and there will be need for public support, because I don't believe that any sector can pay himself or itself for the whole infrastructure needed to ship it somewhere to, I don't know, Norway, or to ship it to the Netherlands and to store it offshore. Or, I mean, we need to have a discussion on societal ground and for other industries and for other sectors. So it's not a topic we can save in this.
Perhaps you can come in on this rather.
Additional remark on ETS. ETS is designed and was designed and is still for big installations, big emitters, and which can afford and which can technically and which have the resource to measure, to make the measurements, to be embedded in national emission plans, and so it's quite complicated machinery. So waste to energy installations are not all that level, that size. Some installations are very big, and many other ones are small ones, like SRF boilers, which can be small-sized installations. And the ETS is obviously not practicable for them, for any reasons, the reasons I mentioned. So also, the whole waste management sector does not account for many emissions in comparison to other sectors. This is why, and waste to energy is 1.5% of the total EU economy. So, all in all, the European Commission decided to keep the whole waste management sector in the ESR, which has now to do lots of much bigger efforts, ambitious efforts. So, don't doubt that the constraint on reducing emissions will be strong, but not based on an instrument like ETS. It will be based on other constraints.
So what's your view on this? The waste is still under the effort sharing regulation rather than the ETS. Is that a good choice of the European Commission?
It's a very good question, and it's one with a lot of aspects. So I'll try to make my response quick. But first of all, the ETS, it was indeed kept outside ETS, but there are some member states that actually chose to opt it in, if you can call it that. And so I don't have the list in front of me, but I know some member states actually included the waste incineration in ETS. Now, of course, as Patrick referred to earlier, the 40% or whichever percentage in each plant you have, which is biogenic, would be outside of that. So you still wouldn't have a clear mechanism to implement, say, 100% capture if you're going to do CCS on such a plant. And that's the general, of course, issue with the treatment of biomass in the EU, that everything is counted as neutral, whatever emission point source or wherever it comes from. But just on the point of the ETS, I don't really have a strong opinion. I know that what we've seen in many cases with ETS is that it's been used as an argument against doing anything. So, government will say, well, if we do reduce emissions on this plant, then it will be cheaper for whoever, a coal plant in Poland or someone in Spain to emit, because we act here. And so, in a way, you can say that it's been holding back action where it could have taken place, where it could have driven down costs. So I think we need to have a wider set of tools. The Innovation Fund, of course, is part of the answer to that. And we need to, I think, widen it. I work on industry. We've seen, of course, a great step from the Commission in terms of increasing the size of the Innovation Fund, but the allocation for industry hasn't risen a lot, and we need to see a lot more funding be made available to drive down technology costs. Now, at the same time, and that's back to your point about who pays, right? Who pays for emissions? So the principle that is at the basic basis of the ETS is the polluter pays. And I guess you can say waste incineration, but also in many other sectors, there's a question of who is the polluter. So now we're getting into something which is quite controversial, I think. But the reality is that in the case of waste incinerations, it's often owned by the public. So it's the taxpayer that's going to have to pay in some way, or the people who will be, basically putting waste into incineration. And that brings us to the consumer. I think that a lot of sectors, we need to see a shift in approach to make sure that at the end of the day, you pay for the emission you cause. We know, for example, in the cement sector and the steel sector, the increase in the cost of steel or cement that is produced with zero emissions, which is possible to do today, but no one does it because there is no business case for it. It will increase by maybe 1 or 2 or 3%. That's max. The cost of the final product. But no one is talking about that. And so we need to see the whole picture of how we finance climate action turn around. I'm not saying that just making people pay more for waste is an easy way to go, because there's a social element in that, and that's true for all of the products that we need to make net zero. There's a product design conversation to be had here in any case, but I think there has to be a way to turn this around and make it investable now, because we don't have any more time to lose.
Let's pick up on that question. Patrick, who is the polluter when it comes to waste to energy plants?
I mean, it's very clear. If you look at who generates the waste, it's not the plant. So there's the first pollution happening, if you like, and that's why it's collected, in order to not pollute. And there are different mechanisms where the people who generate waste pay for this. Municipals make people pay taxes where they use this to have afterwards the waste treatment, overall integrated waste treatment, recycling, composting, anaerobic digestion, whatever you do, and also waste to energy. So that's the clear point. So you're in a two-step approach here. And at the end, the polluter who pays the CO2, if you like, if you call this a CO2 pollution, then you would have the plant emitting the CO2. But it will only add up the cost on the gate fee, because the money must come from the one who makes the waste in the first place. There's no magic, no one else. If you look at a coal plant who shifted to biomass, that's possible. But in a waste to energy plant, you cannot make a fuel switch. Or replacing dirty coal by cleaner gas, you cannot do it in a waste to energy plant. So in waste to energy, you're stuck with the main task you have to do to treat non-residual waste, to avoid pollution, to recycle materials and recover energy. And that's what you do.
And we're beginning to run out of time now, so I'll ask you to give maybe a 1 or 2 minutes of your key points and your key takeaways from today. Jonas, let's maybe start with you.
Right. So first of all, since this was a taxonomy discussion as a starting point, I would like to again say the taxonomy has to be kept as a gold standard. And it's critical. We know that the gas debate is coming up, the whole transition story, all of the pressure that's being put on the Commission from even the member states that often have been, the good guys in the climate debate. There's a pressure to include all kinds of stuff in the taxonomy that isn't compliant with a net zero pathway, and we can't allow that to happen. So we have to find a different way to ensure that these things that may be necessary. And again, we have to look at the numbers. But for me, it is really about, in the context of waste incinerator, even the investments that need to be made into existing installations like CCS and other measures to deal with emissions are not currently eligible. That has to be changed, I think. But so taxonomy as a gold standard. Secondly, and when it comes to the funding, I'm not saying that we should have necessarily every person should be paying for this, but I think we need to find a way to turn this into incentive government also to reduce waste. And that's maybe lacking at the moment. So whether it's the government that pays or every one of us, it has to be turned around so that the implementation of climate measures in the sector is incentivized and reduction of waste is incentivized at the same time. And last but not least, back to your question earlier, you said could this inclusion in ETS boost CCS? I think that's a wrong framing, because we don't want to boost CCS. No one should want to boost CCS. CCS is effectively in some form of waste management as well. It is we have a CO2 problem, and currently we're dumping, billions of tons of CO2 in the atmosphere every year. And that is, you could say CO2 is maybe not the definition of waste, but it's a definition of a massive problem that we have to manage. And so what we want to do is reduce waste and reduce the need for CCS, but at the same time recognize that we're out of time. Thank you.
And Valerie, your takeaway points from today?
Well, I'm sorry, I'm going to repeat that it's essential to address residual waste in the taxonomy, either to make it a gold standard with a focus on selective collection, separating waste and sorting out, which is very positive and which we have to improve, and which we have to justify that the waste-to-energy plant take waste only from those separately selected waste sources, or collected or sorted out. So to make sure it's only residual, but this would be a golden standard in the end. This would be a green practice. And call it green or not, if you don't have such a signal, then you will lack the capacities to properly treat those waste, which is crucial in the circular economy. So I'm sorry to repeat the reason why we say that there is an absolute need to address the residual waste issue in the taxonomy, to make it with green practices or to make it happen anyway.
Thank you. And Patrick, you opened our session. Perhaps it's best that you close it too. What is your takeaway from today?
Yes, over the whole day, it is quite a lot. We had different point of views, but we clearly shared some facts which showed that, in my opinion, residual waste will not go away, should be minimized, can be minimized, but will not go away. And therefore, and closing with the taxonomy topic, I believe that it is absolutely necessary to include, and take your words, gold standard for waste to energy, but to have a clear assessment of the role of waste to energy in the taxonomy, in the environment, in the net zero, what is expected, what can be contributed, because not addressing it will not solve the issue of residual waste. So look at it in an integrated way, look at it in a circular way, look at this in a CO2 reduction way, look into residual waste management needs, and then come up with a support for CCS integration, clarification of the rules for taxonomy, and the definition of the role how the residues which are recovered by waste to energy can be taken up in the economy.
Thank you. And thank you to our audience for joining us today. You can find more Euractiv events on our website, but for now, thank you for joining us and hope you have a good rest of the day. Goodbye.